Yeah, hi. Good morning, everyone. Welcome to the second session for the week two. So, before starting the session, if you have any doubt, any query, Kirtana, Niranjan, Ram, Ram, your voice is not clear.
No, sir, it's clear till now.
Okay, fine. So, we will discuss the practice question today, and we will also discuss about the interface of the programming assignment. So, in week three, actually, that the programming assignments are also released now, and from week three onwards, week three and week four for you as a qualifier. So we will discuss about the interface, so how you can write the code, how you can run the code, everything. So before starting the programming week three things, let's discuss the practice questions of week two. Okay, so let me share my screen, and you can ask your doubts in between if you have any doubt in any question. Okay. Yeah, I hope my screen is visible. Can anyone confirm?
Yes, sir, it's visible, sir.
Okay, thanks. Okay, so these are the basically big two contents are depends on this data representation in the computer. So questions are also based on that. So the first question we have like this 877 in the decimal form. So you know that we can represent the data in different forms like decimal, binary, hexadecimal. So how we can convert the one form to the another form, so that things you should know. So we will discuss the process for the first question. So let me copy this question, and we will discuss the process. Okay, so this is the first practice theory question. Now we have this 877. Okay, so this 877, the form is actually decimal form. So this suffix we are generally represent this as a tenth base. Okay, with base 10. So this is decimal number, and we want to convert that number into a binary form. Okay, so with the base 2. So in binary number, you know that we have only two numbers, so 0 and 1. Okay, so with the help of these two digit, we can generate any number, we can represent any number with the help of these two. So how we can convert the one decimal number to a this binary number. So this is a big example, but we can start with some small examples. Suppose we have one like 14. Okay, so this is a decimal number, and how we can convert this decimal number into a binary number. So what is the process of this? So there is one division method we have. uh, okay, so division method we can also apply. Otherwise we have another method which professor have discussed, so that is actually a 2 to the power form. So like 2 to the power 0, and 2 to the power 1, 2 to the power 2. So like 2 to the power 3. So we can check that what is the smallest number which is closer to this 14, we can represent with this 2 to the power. Okay, so that is actually a 2 to the power 3, 8. Okay, so 2 to the power 3 is 8, and when we move one more 2 to the power 4, so it becomes 16. Okay, so 16 is greater, but so this is 2 to the power 4, and 2 to the power 3 equal to 8. So which is smaller than this? Okay, but closest. So we can take this 8. We cannot take this 16 because 16 is greater than this 14. So what we can do, we can just mark. So this 1 we can mark with this 2 to the power 3. Then what is the remaining value we have after this? So 14 minus 8, we have 6. Okay, so 14 minus 8, we have 6. Now what is the closest value we can represent for this 6 in the 2 to the power form? So if we take 2 to the power 2, so that is 4. Okay, so 4 is smaller than this 6. So that means we can take this 2 to the power 2 also. So we will take this. So 1, we will consider this. Now we will reduce 4 from this. So now we have 2 only. Okay. And once again, next, if we take 2 to the power 2, sorry, 2 to the power 1, so we are getting 2, which is equal to this. So we can take this also, so 1. Okay, and now we have completed. So 2 minus 2 is 0. Now nothing is remaining. So that means there is no value we are taking for this 2 to the power 0. So we will consider this as a 0. So this is the one way to represent any decimal to a binary form. So we can represent like this 1 1 1. So 1 1 1 0. So this is the binary form for 14. Okay, so this is the one way which is discussed in the lecture. Another way we have for division method. So division method is we can start division. So we can start like this. So first, and we will divide this by 2, because we are just converting this decimal number into a binary numbers. Because of that, we are dividing by 2. So if we divide by 2, every time we will just store the remainder, what remainder we are getting, and what is the quotient value we are getting. So reminder we will put here, and quotient value, what is the quotient value we will put below this 14. Okay, so 2 7 is 14, we can say 2 7 is 14. This is completely divisible, so no remainder is remaining, so we can write 0. Okay, and what is the quotient value is 7. 2 7 ja 14. So next we will repeat the same process again. We will divide by 2 to this 7. Okay, so 2 3 just 6. Okay, so we can take this smallest value, but we cannot take 2 4 ja 8, because 8 is greater than 7. So 2 3 just 6. That means the quotient value we will get 3, but 1 is remainder. Okay, so 7 minus 6 is 1. So 1 remainder we will put here. Okay, next again we will repeat this process. So what is the 2 1 ja 2. Okay, so that means 1 is remaining, and what is the remainder? 3 minus 2 1. Okay, and after this, so this we can write one remainder directly. So this is only the remaining one, and we can write 0. Okay, so this is the way of the division, and after that we will read this remainder value from bottom to top side. Okay, so 1 1 1 0. So this is also a similar which we have got previously, 1 1 1 0, and we are getting the same from this method also. Okay, so this is the representation of binary. So this is division method. So in this way we can convert any decimal value to any another base. So similar way, if suppose this 14 is required to convert uh, uh, 10 into the form of octal value, octal base. Okay, so octal base means 8 base. So same method we can apply, but what we will do, we will just use the divisor value 8 here. Okay, so if we use this 8 and we divide 14 divided by 8, so 6 is remainder and 1 is remaining. Okay, so 6 is remainder, 1 is remaining, and after that 8, so 0, and this one is remaining. Okay, so we can read this from bottom to top, and 1 6. So that means in octal form this 14 will be written like as a 6 1 6. Okay, so octal means we have only these digits. So 0 1 2 3 4 5 6 7, only these. Okay, so this is the set of value, set of digit we can use to represent any number. So 0 to 7, total 8 unique digit. In binary we have only 0 and 1, 2 unique digit. In decimal we have total 10 unique digits, so 0 to 9. So in this way we can convert this decimal into a any form, so like this octal or binary. So for this question actually we can solve by the division method. Okay, so 877, and we can start division method. So like we will write like this, or no need to convert completely, because we can also just match the star some bits of the option. And so what we can just simply divide, like, so 2 4 is 8. Okay, and 2 3 is 6, and 1 6, and 2 8 is 16. Okay, and 1 is remainder. Okay, and after that once again, so 2, so 2 2 is 4, and 2 1, and 18, 2 9 is 18. So no remainder is remaining. Okay, so now 2 1, and this is 0 and 9. Okay, and one is remainder. Now from this you can just because we will read this value from bottom to top, so last bits are coming 101, you can see. So now you can see this cannot be the answer because in binary form only 0 and 1 digit is possible. So this definitely we can discard. 1 5 6 this we can also discard because 5 6 7 cannot become in the binary. Now only these are the two possible answer, and out of these you can see 101 we are getting in the last if we are reading in this manner, and this is matching with this third option. Okay, so you can save the time, no need to complete this process. Okay, so it will take more time, but you can do, you can just match the some part of the option if it is matched, and the you are only getting the one option which is matching, so you can simply select the answer. Okay, so 101 this is matched with the third option in the last, and this is not matching in the last. Okay, so you can select this option as a correct answer. If you complete this process you will get the complete this answer. Okay, so in this manner you can compute the one form to another form. So this is first problem. Yeah, second question we have just quickly copy this. Okay, so this is consider a 10-bit integer number used using signed magnitude concept. So that you have already learned in the lecture, signed bit, signed magnitude concept, signed bit. We will also store the information for sign. Okay, so suppose we have some number like 10 and positive 10. So this is a different number, this is different number, this is positive, okay, and this is negative number. So that means we will also store the information in our binary form for this sign. Okay, so that means we will use one bit for sign operand. So here we have total 10 bits. So 10 bits we will use one bit for the sign. Okay, and that means if this is 0, so this one bit, actually if this is 0 that is positive, if this is 1 that means negative. Okay, another 9 bit we will use for the data. Okay, so this is simple sign bit representation. So what we can do, so here range is given, so identify the positive and negative range for this. So we have total 9 bit. So what we can do in the positive side, positive mean we are including 0 also. So that means total how many value are possible. So for if we are starting from 0, so that means 2 to the power 9 minus not here minus 1. Okay, so that values are possible for the positive range, we can say 0 to 2 to the power 9 minus 1. Okay, suppose we have 3 bits, like, so I'm taking small example to understand this. So like we have 3 bits. Okay, 3 bits, or we can say standard 4 bits we have. Okay, and this is sign number. So one bit we will use for the sign, and 3 bits we will use for the number. So in 3 bits we can only represent 2 to the power 8 minus 1, sorry, 2 to the power 3 minus 1. So this is actually 7. And what are these 7 numbers? So we can start like this. So first value is 0, so this is representing positive. Another 3 value will start like this. So what are the possible combination we have? So 0 0 0, so this is representing 0. Okay, and 0 0 1, this is representing 1. 0 1 0, this is 2. And 0 1 1, this is 3. 0, so 1 0 0, 4 1 0 1 5 1 1 0 6, and 1 1 1 7. Okay, so by 3 digit we can only represent this 0 to 7 number. Total we have 8 number. Okay, so this is total 8 values we have, 0 to 7. And after this if we increase one more value for 8, so we have to increase one bit. Okay, so that we cannot increase because we have only limitation with 3 bits. So after that the next number will come with like this 1000, so using this 4 bit. Okay, so for 8, so that we cannot use because we have limitation of 3 bits. So that means we can only use this formula 2 to the power 3 minus 1. Total 7 number we can use the positive side. So sorry, okay, one second. uh, positive side one say okay 3 0 to 7. Okay, so this is range, yeah. Okay, so range is given, so range will move to the 7. Okay, so this 7 value, but total we have 8 value. So range we are checking, so 0, so positive range we will check in the option. So 0 to the power n minus 1, yeah. Oh, this is okay, this is also okay, and these two options are not correct. Okay, so we can directly remove the option based on the half part of the question also. Okay, so that means 2 to the power, because we have 9 bits only. Okay, so 0 to 2 to the power 9 minus 1, this will be the last value, and that means these are the possible answer. But we have to also check the negative side. So negative side also, because you can see here we all are using 0. Okay, but for negative same things we can use with 1. Okay, so that means 1 for 0 0 0, and this is 0 like this mine, so this 1 will represent negative sign. So this is my, this is not, yeah, this is minus 0. Okay, so minus 0 and 0, generally we use the one form in the sign magnitude. Because of that we use a different conversion, that 2s complement. So because in simple representation we have two representation for 0. One is minus 0 and another is plus 0, so there's no meaning for 2 0 actually. Okay, but next one is value is minus 1, so that will be represented like, uh, this is the fourth bit, and this is 0 0 1, so this will be represented by minus 1. So minus 1 to minus 7, so this range will go like this. So 1, and first bit will represent the negative sign, so minus 7. So minus 1 to minus 7, so minus 7 means we can write like this, so 2 to the power n minus, that bits number of bits minus 1. So minus 1 to 2 to the power 9 minus 1. So you can see negative range minus 1 to 2 to the power 9 minus 1. Okay, so this is a negative range. So first option is correct for this negative range. This is for a sign magnitude concept, not the 2s complement representation. Okay, so first option is correct for this. Next, third question. Yeah. So this is related to the 2s complement notation. Okay, so because in the previous example we have found that we have two representation for 0, minus 0 and plus 0. So there is no meaning for this. So how we can remove this okay, ambiguity? So in, so because of that we use this 2s complement notation. So suppose we have 8 bit. Okay, so I'm taking the example of 8 bit, and based on that we will also get the answer for this. So suppose we have 8 bit number representation. Okay, and one bit we are using for the sign here. Okay, but we are using 2s complement notation. So in 2s complement notation, what we generally use, so we use the same notation for 0 to 127. Okay, so here because one bit we are using for uh, sign, and 7 bit we are using for number. So positive side there is no change, we will represent as it is. Okay, so 0 to 127, this will be represented as the similar as the previous. But for negative side, so for negative side what we will do, we will just consider this next value, so 128. Okay, which are coming, so this value we will consider as a minus 1. Okay, and this one next value 129, so 129, this will be represented by minus 2. In this way, last value we have 255, because we have total 8 bit. So that total number of the last value will be 0 to 255. So 2 to the power 8 minus 1, so this is 255 of total 256, and the range is 0 to 255. So this 255 value will be represented by this minus 128. Okay, so this is the sequence we will find out that, and how we can find out any negative number. Suppose we have this 25. Okay, so how we can represent the 25 in 8 bit representation? So this is positive value. So positive value, so that means this is the binary number for this is 8, not 8, 16 plus 8 plus so 1. Okay, so that means 2 to the power 4 to plus 2 to the power 3 plus 2 to the power 0. Okay, so we can write the bits for that. So to 1 and then 1, and then 2 to the power 2 and 2 to the power 1 we are not using, so that 0 0, and then 2 to the power 0, so 1. So this is the positive representation for 25. But how we can, so how we can represent this in 8 bit? So 8 bit representation will be 0 0 0 and then 1 1 0 0 1. Okay, so this is the representation of 25 in positive, that 2s complement notation for positive. Okay, then what is the value for 25 negative? Minus 25. So to find out the negative representation in 2s complements, just find first, figure out what is the value for 25. So this is this one, and after that convert this value into the 2s complement. 2s complement means how the, what is the process of to convert this into a 2s complement? First we will convert this number 25 into a 1s complement. 1s complement process, we will invert all the weights. So invert all the bits, we will make 1 to 0 and 0 to 1. Okay, so just first 1s complement for this number is, so 1 1 1 and 0 0 1 1 0. Okay, so this is 1s complement. So we are simply inverting all the digit 1 to 0 and 0 to 1. After that, for 2s complement, we simply add 1 in this 1s complement. So 1 0 is 1, and after that 1 1 0 0 all will remain same. 1 1 1. Okay, so this is the 2s complement number, and this 2s complement, the first this bit is representing the negative sign. Okay, and this number is representing the 25. Okay, so this 25. So in this form, so this number will be actually represent, if you calculate the what is the actual value for in this range, is, if you calculate this, so 1 1 0 0 1 1 1, so we can write like this. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. Okay, so this means 2 to the power 6, 64 plus 32, then you, both are 0, and 2 to the power 2 4 plus 2 to the power 1, this is 2 plus 2 to the power 0 1. So that means 64 32 96 and 100 and 103. So in range, actually this value is representing by this 103. Mm, uh, 1 second. Okay, so that one number is more there, so yeah, this one, so that is actually 128. So 128 is 31 and 2 3 and 2. Yeah, so this value will be represented by minus this 231 actually in this range. So if we are moving to this range, so this minus I think there's something. 1 second. So 11001. Okay. So minus 1 and 28 is 8000. Minus 25. Okay, I think something. Check again. So 1 1 1 0 0 1. This is for 1. So this is 2 3 4 5 6. This is 64 and this is 32. This is your 0. This is 4 plus 2 plus 1. Okay, and 128 to 31. Okay, so let me just quickly check. Okay, so 1 second. So 17 we have like this, or another way is we can also calculate like this. So to the power, yeah, okay, fine. So how we are getting this value? So we have total 8 bits. So 8 bits we have. So 2 to the power 8 minus, and we are calculating the value for 25. So 25, we can calculate like this. Okay, so 256 and minus 25, so we are getting same 1, and this is 3 and 2. Yeah, so for this value actually we are representing as a 25 in negative, so we are getting the same in the last. Okay, so 231. So this 231, that means the representation, complete representation of 8 bit is actually a positive value. It is representing 231, but in 2s complement it will represent as a minus 25. Okay, so minus 25. So this is a way to represent the negative number in 2s complement. And this is the another representation, because in the previous sign magnitude we are getting ambiguity for 0, and here we are not getting ambiguity because for 0 to 127 we are getting the correct positive integer. After that we are getting the minus, oh, 1 to minus 128. So this is the range. So all actually digits, we have total 8 bits. That means 256 value we can represent with this 8 bits. To the actually representing by this 2s representation. So this is 0 to 120. This is total 128, and this is also a 128. So 128. So all actually possible data representation are we are getting from this 2s complement. So that means, so so this is the representation of 2s complement. Now the question is actually, so you can see in the representation after 127 we are getting this 128. So 127 will be represented like this. So 100, sorry, not 0, 127 means 111 and 111, or 1 2 3 4 5 6 7. Okay, so all are 1. Okay, and first value is 0. So this is actually 127. Okay, and 0 is representing positive sign. The next value which we will move after this, that will become 1 0 0 0 0 and 0 0 0. Okay, so that means this is the form. Okay, so this will be represented, and the last value will be 1 1 1 1 1 1 and 1 1. So 1 2 3 4 and 1 2 3 4, total 8 bits. Okay, so this is the first value, and this is the last value, and we can represent this value in the hexadecimal format. So we will take 4 bit in the combination. So this first 4 bit is representing 8 for a hexadecimal. Okay, and the last value is 4 value is representing 0. Okay, so at this represent decimal we represented by the f. Okay, and the next again, so you can see for negative range is going from 80 to s, 800, this combination, to f this combination. So this is a third. Suppose you have a document which contains only uppercase alphabets minimum. Okay, now this alphabet, so how many uppercase alphabets we have? So that means we uppercase also we have only 26. So every alphabet we can alphabet, so the counting is 26. And to represent this 26 uniquely, how many bits we required? Okay, so for bits. That means we have total 26 unique characters, and we want to represent by the binary number. So that you know that if we have one bit, okay, one bit, so that means 2 to the power 1 minus 1. So two and total one data you can represent for the one bits. If you have two bits, you can represent it 2 to the power 2 minus 1, 3 bits. So that is actually 0, 0, 0, 1. Uh, that okay, so 0. Hmm. So 0, 1, 0, and 1, 1. So this is range actually 0 to 1. Yeah, okay. So if you have one bit, okay, so that this is not correct. Minus 1 is not required. Yeah, for range actually we generally take this minus 1, 0 to this one. So here actually for 1 to the power 1, you can represent two data for one bit. So that is actually 0 and 1. Okay. And if you have two bits, you can represent four value different. So 0, 0, 0, 1, 1, 0, 1, 1. So this is 0, this is 1, this is 2, this is 3. Okay, only you can represent. So four value you can represent. So in this way, if you have 2 to the power of 4 bits, so how many value you can represent? 16. Okay, but we need 26. If you have 2 to the power 5, total 5 bits you have, you can represent maximum 32. So now 32 is the bigger value than this 26, and which is also a closure. And we are asking the minimum number of bits required, because we can also represent this 26 number by this 6 bits, because 6 bits we can uniquely represent 64 unique data. Okay, but we can also represent 26 by 5 bits. So we will select the minimum one, 5 bits. Okay, not, but we cannot represent by the 4 bits, because the maximum number of data can be represented only 16. So here we have 26. So we will just pick the just upper one. Okay, just upper value. So what is the minimum bits of required? So this is 5. So total 5 bits are required to represent 26 unique data for this representation. Okay, so 5 will be the something is okay. So the tool is not opening. Just give me 1 minute. The system is hanging little bit. Okay, so I'm just giving the clarification from the question page also. Okay. Which of the following assembly language instruction can be? That means we have one register R2, and we want to store the value from this things for us. Okay, so 0. So that means this instruction actually shift the 0 value to R2 registers. Okay, so this operation actually move the value of 0, which is written in the second operand. So second operand is 0. That value will be moved into the register R2. So finally we will get the 0 value in the R2. So this option is correct. Okay, this is performing the above task. Next is add R2 0 0. So this operation is performs of the first operand, second operand, and third operand we have. Okay, three operand we have. So what happened? This add operation actually perform the addition operation on second and third. Okay, so what is the second operand? Zero. Third operand is zero. So add zero plus zero, and after what is the result we are getting? That result will store into the R2. So that means finally we are getting 0 in the R2 register by this operation. Okay, so this is also correct. Sub R2 R1 R0. So that means this operation subtract the R1 minus R0 and store the result into R2. Okay, so what value we have initially in R1? This is 1, which is given in the question statement. R1 always holds 1 and R0 always holds 0. So 1 minus 0, we are getting 1, and 1 value will be stored into R2. So after performing this operation, we are getting 1 value into the R2, but this is not our goal. So this third option is incorrect. And next is add I R2 R1 0. So this operation also perform the addition of the constant value into the register value. Okay, so the constant value is 0 here, and 0 value will be add into the value which is inside the R1. Okay, so R1 value we have 1. So 1 plus 0, we will get 1, and 1 result will be stored into R2. So that means in fourth option, we are getting a 1 value into the R2. So this is not our goal. So that means the first two operations are actually fulfilling our goal, 0 value into the R2. So the first two operations are correct. Okay, for the fifth. A collection of 4 bits is called as. Okay, so this is regarding the data, some term actually used in the computer. So word is actually also a collection of bits, but it is dependent on the machine. So that based on the machine, it is decided that what is the size of word in the machine. So any 36 32 bits machine is contain the different size of word, and another 64-bit machine is contain different size of words. So this may be different for any machine. Byte is the unit that contain 8 bit. Okay, so when we have 8-bit combination, we generally call as a 1 byte. Okay, if we have 16 bit, we call as a 2 byte. Okay, so in this way we can represent the data. So 1 byte means 8 bits. And nibble, yeah, so this nibble is actually a collection of 4 bits. Okay, if we have 4 bits group, then we can call it as a 1 nibble. Okay, this is a unit of the group of the bits. So this nibble is actually contains the 4 bit, and we call it as a 1 nibble. File is simply a collection of data, so there is no relation here. So for this 4 bits, so file can contain any number of bits or any number of size. Okay, so here the third option is correct for the sixth question. Next is, what is the decimal equivalent of the binary number of this representation? Okay, so this is binary to decimal conversion. So system is so we have this okay, 1 0 1 1 dot 0 1 0 1. Okay, so we can just simply use this to do the power things. Okay, so 2 to the power 0, this side positive side, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, and negative side 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4. And corresponding bits we have 1 0 1 1, and then decimal, and then 0 1 and 0 and 1. Okay, so we can simply multiply this. So 1, sorry, this is 2 to the power 3. So 1 into 2 to the power 3, so this is 8. Okay, 0 into 2 to the power 2, it will become 0. So 1 into 2 to the power 1, so it will become 2. And 1 into 2 to the power 0, so this is 1 into 1 will become 1. So this is the positive side. And in the negative side, 0 into 2 to the power minus 1. Okay, so 1 minus 1 we can write like a 1 by 2. So this will become 0. Okay, first thing. Then plus 1 into 2 to the power minus 2. So that means 1 by 4. Plus again the next value will become 0 with this. So this is 0 multiplication. And next will become to 1 divided by 16. 2 to the power minus 4. So 16. So when you calculate this, so what 2, 8 plus 2 and 11. So this will become 11 dash. And what is the value for 1 by 4 plus 1 by 16? Okay, we can write like this. So simply 16, and here this will be, so 3 48 and 2, then 1 like this. Okay, so 0.31. You can see option D are matching 11.31. Then we will also get a binary number into the decimal number. The binary number is this. If one of the number is this, you can simply find out the decimal equivalent for this. Okay, the sum of a decimal number, and one number is given, another number is asking. Okay, so simply you can perform the this operation after converting into the decimal number, and after getting the result, just convert that number into a binary number. So some binary to decimal, then decimal to binary conversion is required. For this, you can easily convert. Okay, so let's convert this. Okay, I'm copying this version. Okay, so here you can see first total sum we have. Okay, so sum we have 1011101. Okay, so what is the decimal equivalent for this is, so we can write like this. So 1 2 3 4 5 6 7, we have total 7 digit. Okay, 4 7. Okay, so this is 2 to the power 0 we have started, and this is the sixth bit. Okay, so 64 and plus 32 is not there, and that 4. Okay, so yes, 16 plus, then this is 8, 2 to the power 3 8, plus 2 to the power 2 4, and then 0, and then 2 to the power 0 1. So this is the value, equivalent value we have. So 64 plus 16 80, 88, 92, and 93. So this is the sum value which we have given. Okay, another value we have 101101. So this is total 6 digit we have. Okay, so this is 32 plus, then 16. So 2 to the power 4 we will skip, and 2 to the power 3 8, plus 2 to the power 2 4, 2 to the power 1 we will skip, and 2 to the power 0, so that we will write 1. Okay, so 32 plus 8 40, 44, 45. So 45, then we will subtract this. So 3 8 and 4. So what is the equivalent value for 48? So 48 we can write like this, 32. Okay, 32 plus 16, we are getting 48. Okay, so 16, and plus all value will be 0. So 32 is written like this, 2 to the power 5. So fifth, this is 1, and fourth is also 1, and remaining will be 0. So 1 0 0 0 0. Okay, so this is for 4, this is 3, this is 2, this is 1, this is 0. Okay, so you can find out the answer for 1 1. Yeah, first option correct for this. Okay, So this is decimal. Okay, so this is very easy because answer will become, because this is sign magnitude by any number. After that, we have only this 4-digit one, and our remaining are 0. So this 1 value is actually represented 15 in decimal. If you calculate this by the calculation, so that 2 to the power 3, 8 plus 4 plus 2 plus 1. Okay, so 8 plus 4 is 12, and then 2 and 1. So this value will be represented by 15. So total value will be represented by minus 15. Okay. Sorry. What is the 2s complement of binary number? Okay, so here 2s complement is asking. Okay, this is not a representation. So what is the 2s complement for this value? So I have already discussed the process of this. So what we can do, we can just convert first into the 1s complement. So 1s complement process is, so I'm writing here, so 0 0 1 1 0 1 0 0 1 0 0 1 1 1 0 0. Okay, so this is the number given, and we want to convert this number into a 2s complement. Okay, so 1s complement will be just invert all the bits. So 1 1 0 0 1 0 1 1 0 1 1 0 0 0 1 1. Okay, so this is the 1s complement, and 2s complement we will add 1. Okay, so we will add 1, so that means 1 add. So addition will be performed like, so 1 1. So in binary number we have only 0 and 1. If we are adding this 1 1, we are getting 1 1 operation is performed by the 10. So that means we will get one carry like this. Okay, so 0 1 plus 1 10, so one carry will come here. Okay, so 1 plus 1 again 0, and one carry we will get here. Okay, and 1 plus 0 is 1. After that, all data will remain same. So 0 0 0 1 1. Okay, so the data will be option with this. Yes. Okay, so these the things we check. Okay, so 1 1 0. So we are adding 1 in this. Two is complement. Okay, so you can see the last matching. So 1 0 0 1 0 0. This is matching. So we can just find this answer 10th. Okay. So next is based on the assembly language. So let me just snapping. Okay. Okay. So here actually assembly language, so instructions are given. If you don't know about this instruction, so because of that comments are also given for each instruction, what operation actually is performing. So here for this type of question, just note down the value of the each registers, what value we are getting in the registers. Okay, so move R1 comma 3. Okay, so this is very small. Let me just increase this. Okay, so move the value R3 into register R1. So that means initially what register actually we are using. So R1 we have in the complete process, R2 we have, Okay, you can note down the all registers which you are using in the computation. So R3 you have. Okay, so initially three value we are just shifting, storing into the R1. Okay, and 8 value we are storing into the R2. Okay, this is the initial value. Now after that, in the third instruction, we are comparing the value in register R1 and R2. Okay, so we are comparing. And next instruction, you can see jump to label 1 if the R1 is less than to the R2. Okay, if this first condition is true, then jump to the label 1 instruction directly. Okay, so you can see the value of R1 is less than R2, correct? So this fourth condition is true. Then we will directly move to the last label 1 instruction, and that instruction is saying that move 10 value into the R3. Okay, so 10 value we will move into the R3. And question is asking what will be the final value stored in the register R3. So you can see in this process we are getting 10 value in the register R3 after completion of this process. Okay, so 10 will be the answer for this. Okay, now the next. Okay, so this is based on the loop control. Okay, so this person, okay, so 2 times added. Okay. So here also we have some registers. So R1, R2, R3. Okay, we have these three registers. So loop, yes. So R1 we have initially 10, R2 initially we have 5, and R3 we have 0. Okay. After that, third instruction loop, start the loop, add R3 and R2. So add the value of register R2 and R3 and store in the R3. So what we are doing, we are adding the R2 and R3 value. Okay, R2 and R, and we are storing the result into the R3. Okay, so that means what we are doing, we are performing 5 plus 0, and we are getting 5, and that value will be stored into the register R3. So that the previous value will be updated by 5. Okay, in the first instruction. Decrement DEC R1, decrement the value of register R1 by 1. So R1 value is initially 10, now we will decrement by 1. Okay, so this will be updated by 9. And jump back to the start of the loop if R1 is not 0. Okay, so that means we will repeat this process if R1 is not 0. So R1 is, you can see, we are getting 9. This is not 0. So again, what we will do, we will perform the R2 plus R3, and we will store the result into the R3. Okay, so next instruction will be 5 plus 5, and we are getting 10, and 10 value will be updated here. Okay, and we will shift this by 8. Okay, still it is greater than 0. It is not equal to 0. So then once again we will repeat this process. So 5 plus 10 is 15. Okay, and 15 we will store here. So every time we are storing the, we are adding the R2 and R3, and we will store the result into the R3. So again, this will be updated by 7. Then still not equal to 0. So 5 plus 15 is 20. So you can see we are increasing in this manner. So you can simply now quickly perform this operation. So 7 now becomes 6, then still there's 25. Okay, then it will become 5, this will become 30, and this is 4, then 25. Now it will reduce one more 3. This is sorry, 35, and this is 40. Okay, and it will become 2, 45. Now it will become 1, then 50. Okay, so yeah, 55. So after that, you can see this now jump back to the start. This last condition is not true, so that our loop will stop. So finally, we are getting value or registers and just update the value based according to the instructions. Which of the following is responsible for managing the execution of program and allocating system? So the resource managing, memory management, all these things simply convert the high level program if is there any error or not. And linker is actually, so when you just include this library in the program, so that is not, but operating system is actually manage all the things, memory, this process management, resource management, memory management, all are the function of this operating system. The booting process. So booting process means when the computer is actually start. Okay, so one part of the code is actually start running before starting the computer. So that program is actually stored in the our ROM memory, which is permanently written, and that is actually started by booting process is actually started by the BIOS, this basic input output stream BIOS things, and when our computer is actually started, and all the resources or all the input output things is actually initialized in this process. So this is BIOS. And which of the following is say machine independent? Yeah, so machine independent language are given: assembly language, machine language, high level language, all of the above. So actually this programming language which we are learning, C programming, Python, Java, C++, all are the actually high level language, and these are designed because this can be run on any machine without depending on the machine configuration. Okay, so this is high level language because we are saying that because these languages are human understandable language, and after some process that language is actually converted into the machine assembly language or machine level language. So that lower level language is actually dependent on the machine, but this higher level language is not dependent on the machine. Okay, so some compilation process we have in the in between in the process, so that is actually convert this high level language to the machine level language. So here high level language is not dependent on the machine, so we can run these in any machine. So this is the answer for 15th question in this second week. Yeah, so this is the last question of practice assignment. If anyone have any query in this practice assignments, you can ask, or any
Sir,
part.
what is the difference between machine language and assembly language, sir?
Okay, so actually assembly language, so machine language, we can say that that what language is actually computer understand. So let me just give one example. I can I'm showing you things. Okay, so suppose we have this hello world program. Okay, you can see in the computer, this is simply a hello world program, and this is high level language we have. After that, let me just run this and show you the how the files are actually created. Uh, run this. Okay, one second. Extra compiler. See. So you can see here when I we have this high level language main.c. Okay, so this is C language code. When we run this code, so actually some another file is created in between. So this .o, you can see this is actually a binary file, and you cannot understand this, and it all contains 0101 in this form data, and this is actually encrypted form. So this is executable file which actually computer understand. Okay, exe file, and that file will be run by the computer, and that is actually binary file. So this is we can say that this is the machine code. And before that we have one assembly language. So you can see this type of code here. Some assembly language are given. That is the one before level of the machine code, actually 0101. So this is the one before code where the instructions are given. So that instruction actually understand by this compilation process, so that how we are just getting the data from memory. So that that is used actually for the communication between cpu and this processor. Okay, so that you can see this move, mov, call, this load, all these type of instructions that is converted by the high level language. So we have only written this hello world program in the c, only this 4 5 line. But you can see the internal when we can run this program, so we are getting this assembly language, not this one. Yeah, assembly language, this program you can see. Here you can see hello world is written here string. And because we are using this header include.h, we are also using this print statement. So print statement internally contains some programming in the library. So all code is actually converted first into the assembly language. So this is the type of assembly language. And after that this assembly language is converted into the machine code or executable code, this .o file. And this file is actually executed by the processor. So this o file. Okay, so computer only understand this 0101 when the processor is actually executing. So that things is actually data is provided in the form of binary, so 0101 form, and that is executable file. Okay, so
Okay, sir. Thank you so much,
yeah.
sir.
Okay, so okay, any other query?
So in week 3 assignment, we have
Mhm. So big
something
three,
other.
yeah. So first thing I wanted to just explain the programming assignment interface. Okay, so you can see in big three now PPA one. This is the actually practice programming assignment. Okay, so there's no marks for this. This is just only for practice. Okay, and after that GRPA one. So this is graded programming assignment one. So these are the question which will be considered for the grading. So GRP 1, 2, 3, 4, 5, 6, 7, 8. So I am just explaining the first programming assignment, PPA1 interface of the programming assignment. So you can see first things you can in the top of the screen. This is the due date. Okay, 31st Jan. And so you have to submit this solution before this date. You can submit multiple times. Okay, so the last submission will be considered for your grading. Okay, before that you can submit multiple times before this date and time. Okay, and this is first thing is the problem statement. And read the problem statement carefully, and after that just check what is the input given to the program and what should be the output coming. Okay, so according to the problem statement, this is the input, and for this input this should be the output. So the one sample input and output is given in the problem statement. So after reading the problem statement, here you have to select language first. Okay, so in this part, only C is coming in this choose language. So select the language first. Otherwise, you cannot write type here. Okay, so you have to select the language first. C. When you select the language, some code is already coming on the editor. Okay, so this is actually a editor, and some gray code is also coming, which is pre-written. So sometimes you will find this gray code, sometimes not. Okay, so this is depends on the problem statement, what actually the problem is asking to write in the editor, or according to the question. So sometimes some codes will be already be given, and the initial part. Okay, so this first part is actually called as a prefix code. And if any code is coming in the later, that is called as a suffix code. Okay, suffix means last, and prefix means first. Okay, and in between you can see the first white space is coming. Okay, so you can type your part of the code in this white area. Okay, not below. You cannot go beyond this suffix code, but in between there is one white line. You can see a white part. You can type your code here. and this is only one line. You can just increase this line, just press the enter. So suppose if you are typing, press enter, you can see this is moving down. Okay, and in between you can type your code. And in this problem statement, the question is asking complete the program to calculate the sum of the first n natural number. Okay, you are given an integer n, calculating the sum of the first n natural number, and store the result in the integer variable sum. So you need to complete this program. That means some part of the program is already given, and what part of the program is given. So you can also increase the uh, this editor size, so from this corner, and you can also increase the font. Okay, this plus sign, and after that you can see we will just understand the line by line what code is given. So that means one function is given. This is the header file. Okay, this header file we are using because we are using this scanf input statement. This scanf is actually input statement, and this printf is actually a output statement. So input statement generally reads the input from the console, and output statement re- print the print some value to the output console. Okay, so this scanf input function and output function is required generally in the most of the program, and we are using this scanf printf directly. Okay, so what is, where the definition of this function is written, that is actually predefined inside this library stdio.h, standard input output.h. H means header. So this library means we have some another program which is already written by the C, and that contain the meaning of this printf and scanf. Okay, we can directly use this function, but somewhere definition is already written. That is actually the library stdi.h. So in most of the program we have to add this library before the programming, writing the program. Okay, so stdi.h, because in most of the program we will always use this scanf or printf statement. So always add this stdio.h library, this line before writing the program. Okay, so this is we have another library also we will use later. So this is the very common library we generally always use. And after that we are writing this one function. So in C actually we write always this main function. This is called as a function. And okay, when function means some block of the code, and we are giving the name of this block as a main function. Okay, so this is the main function of the C program. Our actually the compiler will always start execution from inside this main function. So what instructions are written inside this main, that will execute first. Okay, from the first line. We can also create the another type additional function in our program, but this is the main requirement function in our C code. So every C code actually contains this main function. Okay, that is actually executed by the compiler first. So here this main function is written, and this first thing is called as a return data type. So that return data type means what this function will return inside the code. So for main function generally we write return statement 0. So if this function is returning 0, that means this is giving some information to the computer. And if it is returning 0, that means it is giving this information like everything is performed fine by this program. And there is no error and there is no problem with this execution. Okay, so this is just a information to the OS or computer, that is everything is executed fine. Okay, so because of that, in for main function we generally write this integer return type here. Okay, and return statement 0, return 0. If our execution fails due to some any reason, so in this case that program will return something, another value, return 1 2 3. So actually the OS have some meanings for every return value. So for 0 means everything is successfully completed, executed. So these are the basic structure of the program. We always write this include stdi.h, int main, and this open bracket and then close bracket. Inside this block, we generally write a sequence of instruction which we want to execute. Okay, so this is called as a algorithm or sequence of instruction. So line by line, we will just write a instruction set, and according to that, our program will run. So here you can see int n, because in this program we want to find out the sum of 1 to n. Okay, so n value will be provided by the input, so that means we have to read the input from the console, so we have to write the statement for that. And before you store that value for n, we have to declare this n variable. So that means what type of value actually we are reading. So in the problem statement you can see we are reading integer type of value. Okay, so you can see 10, 5, these are the integer value. Okay, and you are given an integer n. So int n is declared. That means n, we will store some integer value inside this n. Okay, so this is declared. After that, we are writing scanf percentile d and symbol n. So this is the statement for reading the input from the console. So scanf, that means this is our compilation. Compiler will stop this process during this step and will wait for the input. Okay, and this is called as a specifier. So this is the representation. We write what type of value actually we are reading. So for integer value we write percentile d. If you want to read a character, you have to write c. Okay, percentile c. If you want to read a float decimal value, then at that time you have to write the float dot f, percentile this f. Okay, so we have different specifier for different data type. Okay, so here we are reading the integer value. Because of that, we are writing percentile d and comma, and we will write this n. But before that, we are also using this and symbol. So that and symbol is representing that what is the address in memory of this n, because every variable, some memory is allocated to the variable n, and that address we are just representing here. So this is called as a address return. This operator is actually return the address of the variable. So on that address, what value we are reading, that value will store on this address. Okay, memory address of n. So because of that, we will use this and symbol when we are using scanf sign, scanf. Okay, so our compiler will read some value from the console, and that value will be stored in the address of n in memory. Okay, so here now value is stored in the n. Some in between you have to solve the output, solve the answer, and later what we are doing, we are printing the output. So printf is the function to print the output into the console. So same things, we have to represent that what type of data we are printing. Okay, so percentile d, so that percentile d, when we are writing this specifier, comma, and what value we are printing, some variable value we are printing here, sum. So that value will be, this percentile d will be replaced by the value of sum, and that value will be printed into the console output. Okay, so this is the print statement. So in between we have to complete this code. So we need to find out the solution of 1 to n addition. Okay, so we can directly use the formula for this. So first thing, we are using one variable here. Okay, so sum, this is not declared. What type of data we are, type we are using for sum. So we are just performing addition operation of 1 to n. That means we will getting integer value. So we have to declare the variable first. So what we can declare similar to the n. So int and sum. Okay, yeah, so we have declared now int sum, and we can directly find the sum of 1 to n by the formula, if you know in the mathematics. So sum equal to n into, so n value we have, so suppose we have 1 to 5 sum. Okay, so 1 to 5, so we can directly calculate the sum by 5 into 5 plus 1 divided by 2. Okay, so that formula we can use here. So n into, and bracket n plus 1 and divided by 2. So suppose we have n equal to 5, so 5 into 6 divided by 2. So 5, that will be 5 into 3, and 5 into 3 is 15. So that means for input 5 we will get 15 directly. Okay, so this is the expression, and every expression we always close with this semicolon. So we have written two instruction here. So first is the declare of the sum variable, and then sum equal to this expression, this formula. Okay, so compiler will calculate the value for this and store the result into the sum, and that sum variable we are printing in the output. Okay, so this is just a completion of this code. And after that, there are two buttons, test run and submit. Okay, so test run button is actually execute this complete code. Complete code means this prefix, then plus your solution, then a suffix. After combination of this complete code, they will be run, and output should be so this public test case, test run button is actually for the public test case. So this public test case which are visible to you. Okay, so which you can see, if input is 5, output should be 15. If input is 10, output should be 55. You can see the output also for this input. Okay, so some inputs are configured, and you can also see that input, and corresponding output you can also see. When you click on this test run button, this code will also generate some output, and that output will come in this actual output field. Okay, so let's run this. Okay, now you can see status are coming, come summary, all cases passed, public test 5 out of 5 passed. Okay, so public means only these test cases which are visible on the screen. Okay, but these are not the final one. You will not get the marks for these test cases. Some more test cases are also configured which you cannot see. So but if you are writing the code according to the problem statement and your logic is correct, so that means the private test case will also be passed if your logic is correct. Okay, but this is just for the help to understand the output for some input. Okay, so here you can see the output should be exact match. Here you cannot print like this. You cannot change the, you cannot give space additionally in the before printing or something like. So here print statement is already prefixed, so no worry. But when you are printing something from your code, so just print as it is as the expected. Okay, so here the data is matched exactly. Okay, you cannot give the space in 1 and 5. Okay, so if you are printing like 1 space 5, so that output will not match. So your output should be exact match with the expected output. So here now this 5 public test cases are passed. Suppose if I change this formula like -1, so you can see the difference, the expected output and your output, and the status will be different. So here you can see public test case 0 out of 5 passed. Okay, wrong answer. So here your code is actually returning this 10 output, but output should be 15. Okay, this is not matching. Because of that, this test case is failed. Similarly, 55, your code is returning 45. Output is not matched. So because of that, this out test case is failed. So you can just improve your logic and corrected your logic based on the in this actual output or expected output. Okay, if your output is not correct, so we will corrected this logic again, so plus and run again. Okay, but this is not the submission. Okay, and this is just the submission for public test case. If you feel that your logic is correct and all public test cases are passed and your logic is correct, everything, then you can click on the submit button. Okay, so submit button is actually executed the private test case. Similar to this public test case, some another test case is also there, and that is hidden actually, you cannot see. When you click on this public will also run and private will also run, and you can see the message in the below, submission successful, 5 out of 5 private test case passed. If you are getting this message 5 out of 5 private test case passed means you will get 100 marks for this. Okay, suppose if one problem is contains 100 marks, so 5 out of 5 private test case means you will get 100 marks. If you are getting 4 out of 5 pass private, that means you will get 80 marks out of 100. Okay, so you can just divide the marks by dividing the total number of private test case. Okay, here 5 test case we have, so 100 divided by 5, each test case contains 20 marks. Okay, so if you got one private test case passed, that means you will get 20 marks out of 100. Okay, so this private test case should be completely passed to get the marks. Okay, 5 out of 5 private test case pass. If you are getting this message, that means your program is correct, and you will get the complete marks for this program. Okay, now you will get the status change in the top, last submitted on graded. Okay, uh, this lower line is actually for the public test case, not graded public test case, and this is for the private test case. And status is, you can also check, 19th May this time we have submitted, and our all private test cases are passed. Okay, and you can also update later if you got all test case pass, you can uh, left here. Okay, so no need to just change the things. If suppose last time you submit wrong answer, so submission will be considered, last submission will be considered. So if your code one time if you have submitted successfully, so do not change on the solution. Okay, so yeah, this is the things you have to done for the assignments. So this private test case should be submitted. So this submit button should be clicked when you got the correct logic. So don't leave after this test run button only. Okay, so submit is required for the private test case. Okay, so we all have this type of problem statement. So you can see like PPA theory. So here when we select this language, okay, so here same things, we have suffix prefix, but some problem statement maybe you will not find out this both prefix and suffix. So let's check this. So here you can see nothing is written, so you have to written the complete statement here. So you are developing a program like this, so for consistency, here you can see some syntax is given, so you can follow this syntax, and some instructions are also given as a comment. Just follow these comments and write the expression, okay, one by one, and just write this complete code in the editor. So here you have to write the complete code, okay, from the first line, and you have to run this. Okay, so this prefix suffix, these are just configuration. Sometimes you will get prefix suffix code, you have to complete the code. Sometimes you have to written the complete code by your own, okay, after understanding the problem statement. So this PPA we will discuss on the next Friday, not Friday, not Thursday. Okay, so we will discuss all the PPA solution on the Thursday, and then we will give you more details. Okay, till then you can try. If you feels any problem in programming assignment, you can also post on the forum. Yeah, okay, so this is about the programming assignments interface. If you have any query, you can ask. Yeah, any query, anyone regarding anything?
No, sir.
Okay, fine. So just try to complete all these programming assignment by before the deadline. Okay, do not try to submit on the last day. Okay, just complete before that. So maybe some portal or internet issue, maybe we will face the problem in the last time. So you will not get the time to resolve also. Okay, sometimes what happens, students submit the code submission on the last time, on last date. So at the time if they are facing some problem or some issue from the portal, so that they will not get the proper time to resolve them. Okay, so just try to complete all the assignment before 1 or 2 days of the deadline. Okay, so this should be the, yeah, okay.
Okay, sir.
Okay, any other query, any doubt you can ask. Otherwise, you can also post on the forum. Nobody, you are not using the forum till now. Okay. Okay, so we will discuss the all programming assignments in the next Thursday session. Okay. Then if there is no query, then we can close the session. Thanks, everyone.
Thank you, sir.
Thank you, sir.
Okay, you're welcome. Okay.
Sir.